Hey, good evening. Welcome back, and welcome to the start of season two. I'm calling it season two because it's been like forever since I've done one of these. And with The Mandalorian season two starting tomorrow, I figure I'd get a jump and provide some content because there isn't any way I'm doing this tomorrow night. Actually, I have other plans, but anyway. Um, so I want to kind of jump into it. The first series has been very well received. It's been great. The content has gotten a lot of views on it, and not enough for me to retire yet. But hey, it's a niche market, so it's all good. Um, but I wanted to start off and kind of bring things around with an update and start with a fresh sample. I feel like we put a lot of stuff into the Twitch sample from last season. We put basically almost every feature of MassTransit into one project, and it really became kind of like I mean, it was a lot of fun. There's a lot of stuff in there, but it's a lot to consume. And there are two areas where I think I got a lot of questions about, could we go into more detail on, or could we get some more information on? And those two areas are obviously the state machines, because there's a lot of depth there and a lot of capabilities in the Saga state machines. And the other one was routing slips. So I think what I'm going to do is I'm going to start with the state machines, and I've kind of come up with a domain that I think is going to be pretty slick. If anything, it's something people should understand, and I'm basing it around a library. Libraries have books. People can reserve books to check them out. They can check out books. They can check in books. So it's a little bit away from the supply chain order management type stuff and more focused just on how we can think about the essence of that domain of having a book and someone creating a reservation, and reservations having expirations, or once they check it out, it actually checks out the book, and the reservation is then committed at that point, and it's a checked out book, and when's it supposed to be returned. So I feel like there's a good essence of scheduling, the different capabilities of the book, checking out the book, producing events when reservations expire, things like that, and how we would handle that in a domain that's fairly concrete and doesn't have a whole lot of external interaction to it. So I've created a project. I saved the file new project, energy for that, and the project is already up on GitHub. And I'll send a link to that in the chat shortly. So I'll jump into Writer because everybody knows I use Writer. This is a .NET Core project. And the first entity, for lack of a better word, that I wanted to focus on was the book. And this is going to focus on the book, and I'm coming at this from a unit testing perspective of I want to be able to add books to the library, because a library is pretty worthless if you don't have books to check out. So I wanted to start it, with having nothing there and being able to just add books to the library. So I'm going to start with what a book is. So a book is just a class, and this has to be something that you can persist, because ultimately you're going to put this into a Saga repository, which is going to persist that Saga state, when messages aren't being received. Sagas within MassTransit, there's two different types, and there's a number of things that go all the way back to sagas. But sagas, and particularly in the state machine sagas in MassTransit, they have their state. They have state that is stored in a repository, and that repository can be MongoDB, EF Core. It can, there's a whole bunch of them. There's about 8 different Saga repositories. And messages can be directed to those Saga instances by being correlated through a correlation ID. So the advantage of that is if I just had a consumer that was using up memory, that consumer is stateless. It does some things and it goes away. By using state machines and directing messages with that persistent state, MassTransit is able to coordinate and correlate those events to Saga instances, load those from storage, execute the events against those sagas, and then persist that changed state back to the Saga repository. And that includes a number of concurrency controls so that you don't lose, so you don't have multiple messages creating multiple Saga instances and things like that. And so we'll kind of talk deep about how that works as well. So to create a state machine Saga, the first thing we have to do is create a class that implements Saga state machine instance. Now, in this case, I've created book, and book implements two properties are required. The first one, which is in the interface for the Saga state machine instance, is the correlation ID. In MassTransit, all Saga instances are correlated by a correlation ID that is a GUID. You can correlate events based on other properties, but that GUID, a correlation ID, is that unique primary key for that Saga repository. And everything can correlate back to that. Now, most database storages and repositories of that nature support creating index properties based on these entities. So you're able to do things like, oh, well, I want to index on ISBN, and I want to be able to correlate events by ISBN. Well, you can certainly do that, and it's supported. But ultimately, a correlation ID has to be created and stored as that primary key for that table that stores that. So the other required property, because we're doing a state machine saga, is I need to have a place to store the current state. The current state, the two most common ways people store it in a saga repository is either an integer or a string. And the string obviously gets big and fluffy. The integer, you have to take some extra care to ensure that you've assigned unique integers to those states. But again, once you set it up, it's pretty easy, it's pretty painless. I've also put a few other properties in here because, as I said, I'm going to focus on just adding one of these state machine instances to the Saga repository. So in this case, I'm going to have a date added, which is just a timestamp of the date that the book was added to the library. And I've just put a simple title and isbin for the book because I want to be able to show some information. I'm not going to expand this into like a fully fleshed library domain, but I think it's enough with title and isbin that we'll be able to do enough searching and stuff on it for now. So once I've created the Saga state machine instance, I then have, this is the data that's actually stored in the Saga repository. And this data is used by the state machine. So the state machine is a different class that inherits from MassTransit state machine, passing it the generic type of that book instance that I had. And in this case, I've already written some code here to handle the initial event of book added. So within MassTransit, all messages have a message contract. And the message contract I've created so far is called book added. This simply includes the book ID, a timestamp in signifying when the book was added, an isbin and a title, so that we're able to actually add that to create a Saga instance based on that information. So that's what I'm going to add into this state machine. So within the state machine, the first thing that I have to do is define states. So when a book is added, I want it to be available. So I've defined a state called available. And these are just added. MassTransit initializes these automatically for you. Thus, the unassigned get only auto property disable that I put on here so it doesn't keep trying to tell me to add some setter to it. MassTransit will enumerate all the states in the type and initialize those to the appropriate types. The event of added, it will put a default initializer on this, but because we're using that book ID to correlate this back to the state machine instance, we have to tell MassTransit how events are tied back to the state machine. So in this case, I'm specifying that the event named added, and I'm just using a reference here to get the property on the type, and I'm telling it that I want to correlate by the book ID property in the message. This is going to do two things. It's going to create a query so that when the message is received by MassTransit, it will go out to the Saga repository and say, in SQL parlance, select from table where correlation ID equals book ID. And at the same time, it will also say, if that does not exist, and this event can start or create in a new instance by being present in the initially block, in the event that a new instance for the Saga is created, it will initialize the correlation ID of that Saga to be equal to that book ID. And it does that automatically based on correlating to that ID. So that's one form of correlation. In a subsequent episode, I'll go into some of the other types of correlations. I want to kind of stick on track here. So that ties me back to the correlation ID product or property of my book. The next piece that I have to specify is the instance state. Because current state is an integer in book. I'll split this out here. Because current state is an integer, I need to tell it which states to add. And because of the way the instance state is here, if I look at the help text, which is probably pretty small remotely, 0 is none, meaning there is no state currently present. 1 is automatically assigned initial, which is the initial state that a saga instance is created on. 2 is final, which is the finalized state of a saga. And those are 2 pre-allocated, predefined states within a state machine. And then 3 onward is the rest. So in this case, available is going to be mapped to number 3. And I would just continue to list out, any of the states in order. It's important to add them in order and never change them, because if you change them, the saga instances that are persisted in your database are going to be all out of whack. So always add to the end and never change any of the ones in the previous. If you delete a previous state, leave it in there, just mark it with comments or whatever in your code as obsolete, just not use it, because if you change the position in the instance state argument list, it uses that position to assign those IDs for the integers. Obviously, if it was a string, you don't have to specify any of this. It just writes the string name of the state to the actual Saga repository. So that's the 2 required properties that are on here. The other ones are ones that we're just filling in. So with just those 2 things defined, the state machine will work just fine, but we have to give it some behavior. And the behavior that I'm going to put in place is I want to be able to add a book to the Saga repository. So when I add a book, the first thing I'm going to say is initially, which says that if this event is received and does not correlate to an existing Saga instance, create a new instance and then do the following. So initially, when added, which added is the event that is triggered, and I'm going to show a feature that I use quite a bit here. I actually can create extension methods to give names. Oh, I have to sign for a package. Hold on. I'll be right back. The times of everything showing up at your house instead of having to actually go to the store. Okay, so back to where we were. So what I'm doing within this initially is by declaring this in the state machine, I'm saying initially, meaning for cases where an event does not correlate to an existing Saga instance, when added, that's the event that I'm specifying. And in this case, I want to say copy data to instance, because I want a descriptive name. I could do this in line and just put then, and this code right here, because I want to copy the properties out of the message and store them into the Saga instance, because by default, the only property that's initialized is correlation ID. And then current state will be set to initial as well. But I have to use this 2 places because added might come later, and I think that's probably being presumptuous on my part, but added might come later. So what I do is typically within the state machine is I'll create some extension methods to just give names to things that I do more than once. So I could leave it just like this and take this code out right here, and we would be good to go. And basically it would just say, hey, for anything that's added, it's only going to be allowed to add it once. You can't call add twice. And that's totally fine, because I just don't really think that we would ever have a book added more than once. But I like to put some description into the code so that I can see what's going on. So I'm going to roll this back, and I'm going to just put that as an extension method called copy data to instance and transition to available. This will make more sense once I actually add more initially events. But given that I only have 1 right now, I can just take this out because I'm not going to do that. we'll YAGNI that and just say that we don't need it, and we're probably never going to accept an added afterwards, so it's not even worth messing with. But still, it's kind of nice to be able to just put the extension method in there to provide something other than a comment of what's going on. So now that I've set up that initially and I initialize that instance, I want to be able to test that this works. And this is going to be probably a big part of the remainder of this particular episode, is I'm going to go into how I can unit test this. And I'm going to set us up for the future. I'm not going to do this in the most simplistic way possible. I'm going to think about the kind of things I'm going to do, because with these books and with the state machines, right now I'm just doing work inline, but ultimately I want to add like custom activities and activities that can do things to the state machine that aren't just inline code within the state machine itself. And to do that, I'm going to want to put those I want to be able to resolve services from like a dependency injection container to produce events and things like that from those. So I'm going to want to set this up to be like a real application, and I want to be able to unit test those things. And if you go out to search Stack Overflow or just look in the chat history, one of the most common questions is, how do I unit test my state machines when they have custom activities? So I wanted to make sure that that was something that I definitely covered in this. And so I wanted to do this for real, versus just, knocking together the simplest thing that could possibly work and then having to go back and look at other things. So all I have created so far is my Saga instance, my state machine, and a single message contract called book added. And those are the only types that I have in my system right now. I have another project that has my unit tests in it. And within the unit tests, I'm going to throw the state machine over here because that's what I'm going to test. I have a unit test written here called when a book is added. And I have this state machine test fixture, which I'm going to go through in extensive detail because that's what's setting up the container for me. But I wanted to show how you can set this up for real. So I have this state machine test fixture that takes a book state machine and a book. And those are the two types that I need to know about for hosting my state machine. And then I do something fairly simple. I create a new ID for the book. I set up the book so that it has the book ID. I initialize the message. I'm just publishing a message saying book added. This would be like if someone sat at a computer and checked in a new book that was added to the library. I put the isbin in there. I put the title of the book. Obviously, I use Neuromancer because, hey, it's one of like the greatest, cyberpunk type fictions ever. And then I'm going to do some assertions against that. So before I go too much deep into this test fixture, I could run this and you could see that it would work. And I'm putting some assertions in here using the MassTransit testing namespace for things like the test harness, like, okay, well, when I publish this, was it consumed? Did someone consume book added? Did the saga actually consume book added? Was a saga instance created with the correlation ID of my book ID? Was a saga instance created of the sagas that were created in this unit test? Is there one in the state of available that has this saga ID? And all of these assertion test methods are async. You'll notice they all have awaits on them. Except for that one, which is weird. I'll figure that out later. All of them have awaits on them because I'm actually waiting for things to happen. Everything that happens in MassTransit is asynchronous, even in the InMemory test harness, because it's actually dispatching messages through the TPL on separate threads. So if I were to just immediately go to the saga repository in memory and say, hey, is this saga there? Chances are it isn't, because the message more than likely hasn't been dispatched yet. So all of these methods that check these collections and have these filters on them are asynchronously checking up to a certain timeout value to see if the repository eventually meets that criteria. And there's some background threading things, so it isn't like polling slowly. It uses some monitors and some thread tools to kind of make this happen in the background fairly efficiently, so that the tests run very quickly. Because if we didn't do this, our assertions would be unpredictable, and it's just nuts. So we put this in here, and a lot of these test harnesses within MassTransit are built to support asynchronous testing of these state machines. So we aren't faking things out. We aren't just like pushing a message through a interface. We are testing serialization. We are testing writing it to a transport. We are testing headers. Everything related to using messaging within MassTransit is tested using the test harnesses. And by that nature, we have a pretty good certainty that even with an in-memory unit test, our stuff is going to work. So these are async, and that's why you're going to see that. This is actually, it's synchronous async. Under the covers, it's basically waiting, so it's a blocking wait. So it eats a thread, but it's doing it in a way that's not horrible. I think there is an async version of this with the saga harness.exists, which we have to await, which again, we'll wait until a saga exists in the state that I'm asking for. And if I were to run these, I would actually see that they actually pass. And I can see that when I run things with the test harness and the way that I've set this up, I can see that, and if I come in here and look, I can see that the setup, I can see that endpoints were configured, my state machine was configured, all of the logging is put out. I've already included quartz in here because I'm going to do scheduling, and I'll show that in the test harness in a few moments. But I have all the logging. I can see when my endpoints are started. I've started the host. All of my endpoints started up. The scheduler started. Everything went there. I can see where I created the send transport to publish the book added message. I published it. I can see where the saga created an instance, added it to the saga repository, and completed the receive on that endpoint. So I'm able to not only know that the test passed, but the way I've set it up in here, I can actually look at the logs and kind of confirm what I expect to see has actually happened. So it gives us a lot of flexibility. And this is something I would really use to like debug and troubleshoot, because I have the debug level logging. I can see all the details of how the bus is set up. So I'm able to see any errors that happen or any problems that happen. For instance, if I were to come into the state machine and comment this out, and then run the test again, it would actually fail this time. Because, and you'll notice it failed quickly, all of these awaits over here, like testing for consumed, they know when the bus is done. So when the bus goes inactive or idle, and basically the test harness knows that there aren't going to be any more messages produced, it short circuits all of these collections so that they know they're completed. So your test doesn't just sit there and run for 30 seconds waiting for some condition to be true. It's already checking, and it says, okay, basically the bus is done. There aren't any messages being produced. So any assertions you have now will not have happened. And if I go then and look in the logs here, I can see, well, what happened? Oh, I created a send and receive, and I received a message, but it isn't actually accepted in that. It isn't actually consumed by that type. So that publish just went nowhere because I wasn't consuming it in there. Now, if I came in here and did something else, like say, instead of initially, say I said during available, which a new instance isn't going to be available. If I run that test again, it'll short circuit out. Message was not consumed by saga. This time it was, because previously it said message was not consumed at all. Now it's saying message was not consumed by saga. And why is that? Because the saga doesn't support it in that instance. So again, a little difference there. Whereas before, that event type was not even part of that equation. So let me put this code back to where I have initially, and now if I run it, the test will pass. Okay, so now we're all back. We can see that we sent the message, the saga was created, added, and then our receive was completed. All of those assertions passed. So we're able to test and verify that that happened. So the next piece that I want to go into is what this state machine test fixture looks like. Because this was created in response to a number of questions about how do I test a real state machine with activities and all of that stuff. And you'll notice I put this in place because I want to be able to test a lot of things. This is just a base class. There is nothing else in here. There are no other dependencies on MassTransit other than the properties that we have in here. So you could write this in line. I just want to make it as a base class because I want to be able to test that state machine in a number of different scenarios without copying that code all over the place. You can see that I'm using MSDI, so Microsoft's dependency injection extensions. I'm creating a service collection. I'm adding a test output logger factory, which is just my implementation of it returns everything and just writes it out to, I think it's the test execution context. It writes it out so that it shows up properly in the test output. So if you're doing concurrent tests and running parallel tests, it doesn't just write to console and become a jumbled mess. It writes to the actual test context, which I use NUnit, so test context is there. If you're using something else, you'd need to find out what that current text context was. I think Microsoft has something in their test adapter now that does that. I'm also within the service collection saying add MassTransit InMemory test harness. Now what this does is this will configure the container so that it's using that InMemory test harness. And then I'm coming in and saying, okay, well, just like I would configure using add MassTransit for a container, I'm saying, okay, well, I want to add my state machine. I'm going to use the in-memory repository. I'm using the publish message scheduler, which just means that I have a scheduler built in that I can use. And then I have to then add the saga state machine test harness, telling it the state machine type and the instance type. And what that does is it will add the state machine test harness to the container as well so that I can check things about the saga. I put a configure services method in here, which just lets you override that in a base class in case there's other things you want to add to the container. I configure logging. So because I've created that logger and added that iLogger factory to the collection, within configure logging, I'm just getting that iLogger factory out. And in this case, I'm configuring MassTransit's log context to use that logger factory because with the test harness, we aren't resolving MassTransit from the container proper. We're kind of forcing it in there with the test harness. And I'm also configuring Quartz's logging, which seems kind of similar, to use that same logger factory so that Quartz logs are actually written out as well. I also have some methods in here to intercept the Quartz system time components. And what this gives me the ability to do is during my test, I can say, okay, well, like later when I start to write a test that says, okay, I want to reserve a book, but reservations say only last for 48 hours. Within a unit test, I'll be able to say, okay, create a reservation. Okay, now make it 2 days later and assert that the state machine has canceled that reservation automatically based on a timeout being sent through the scheduler. So that's kind of a sneak peek of what's going to be coming up and why we're setting this stuff up. But I wanted to have Quartz in the container as well. So, and again, nothing really talks directly to Quartz. Everything is through messaging. It's just having it set up in memory so that I'm able to test that scheduling capability. So once I have those added and the logging is added, I then resolve the in-memory test harness from the container and I just store that in a property. I also set up I intercept the creation of the bus so that I can add the Quartz scheduler, the in-memory version of Quartz. And then I start the test harness. After I start the test harness, I resolve the saga harness by just getting the state machine saga test harness out of the container. Why those generic arguments are backwards, I don't know. It should have matched the others, but if I change it now, I break people and it makes them mad. The 8 people that probably use this feature. And then the other piece is I resolve the state machine from the container as well so that I have that as a property. So that's all that is doing. Once that is in place, it makes it really easy to write additional tests around this so that I don't have to do all that boilerplate code every time. So anyway, that's where we're at with kind of where we want to go with this next series of videos. So far we've covered just the basic domain of the book. We have the book state machine. We have the first test on that. We have that we're verifying that when a book is added, it runs. We showed how to show the logs in the tests, how to assert things like where messages received, where messages created. I am going to cover one little extra bonus thing that I think will be kind of fun. Actually, it's not fun. It's just something that's convenient. I like to think it's fun, but really it's just kind of a feature that's been introduced that is probably poorly documented, but it's worth using. So this event definition here, there are ways around this. Some people have asked, well, I have all these events and I know that they correlate on my own thing. They correlate on book ID. And I hate that I have to go into every system and tell it that book ID is its correlation ID. So one way that I've kind of gotten around this, and I don't really know where to put it yet because static initializers are kind of weird. So I think what I will do is I will just put a class inside the contracts. And I don't know what we'll call it. I think we'll just call it message contracts or something. But what I want to do is I'm just going to create a simple static class called message contracts. And then I'm going to create a public static void initialize. And I want this to be called more than once. So I'm actually just going to put a static initializer in here, which will get called anytime you call initialize. So initialize isn't going to do anything, but it will call the static initializer. And you know, maybe I should have like a static bool initialized, and then if it's initialized, return false. That's probably safer, because that way I don't get screwed in the type initializer exceptions that happen. But what I want to do is I want to be able to have a place where I can initialize my message contracts and say, hey, always correlate by book ID. Because what's going to happen is, and let's show the failure case here first. If I go back to the state machine and I take this out, and then I try to run the test, I will get an error at startup that says, hey, I don't know how to correlate this. Failed to create state machine connector. State machine was not properly configured. Added was not specified. And added is the event that I'm using, but it wasn't specified. It doesn't have a correlation type. And I need that to be able to know how to correlate to book ID. Well, I want to fix that, but I don't want to do it every place I use it. So one of the features of MassTransit is I can actually, because this is a global message type, I can go into the global topology, which is the message topology. And I currently don't have MassTransit in my contracts package, but we're about to get it because we're going to probably use it anyways. Why not, right? And so we're going to say global topology.send, because anytime send is run for everything, and I want to say use correlation ID, and I'm going to give it that message type, which if I recall was book added. And I'm going to say book ID is the correlation ID for that type. And then I'm going to set initialize to true so that I don't do this more than once. And so what this is going to do is it's going to tell MassTransit's topology conventions, hey, anytime you see this message type, assume that the default correlation ID is book ID. So now, if I come in here, it should pass, but it didn't. Why didn't it? Added was not specified. See, oh, because I didn't call message contracts initialize. So now if I come in here, and again, I'm moving the weight here, and I don't know of a better way to do this yet, but if I run it this way, see, the static initializer is fairly clean. It didn't get it that time either. I wonder why. Seems kind of whack. Initialized is true, return, otherwise do that for book added. Huh, I wonder why this isn't picking this up. Because it should pick it up. I wonder if I still have to add it, but not specify the correlation type. Oop, nope. Click sealed. Try it again. No, it still doesn't like it. So much for the bonus coverage. Basically borked everything because it doesn't work. I bet, oh, I know why. I know why. Okay, I didn't bork anything. It's just I'm dumb. So the problem is this isn't called until the test is run. The test isn't run until the base class initializers are run. So that's going to be a real pain. Yeah, so I guess I could put a static initializer here, which just seems really wrong. Basically, I have to make sure it's called initially. It has to be called before the initial setup for the state machine is done. See, now it works because it's called at the right place and time. So anyway, somehow you got to figure out how to get that static initializer called, and I don't know how to do that with like an assembly being loaded. So, but that would be a cool thing if there was an easier way. I usually just put this at the beginning of my startup.cs so that I initialize my contracts and they're there. Another place I put it that I've found is pretty useful is if I know I use a contract in here, I'll just put it in here within the state machine. And then if it's already been called, it's called, but I'll know that it's only been called once, but at least it's called before it's referenced, because referencing the state machine is going to reference the type. So again, it's how do we force that initializer to get called? So now I don't have to specify the correlation type with every single state machine or every place I use that message. So a little bonus coverage there. I'm sure there's probably a better way to get that static initializer called, but it just specifies that global topology data. So that's going to be where we're going to start. I'm going to take a break. I might do one or two more of these tonight, just depending on how much further I want to get today. But that's where we're at so far. These will be archived on YouTube, so Twitch only keeps like 60 days worth. So they will. I'll create a new playlist for this season in YouTube on the YouTube channel. Oh, and the other piece of the puzzle is the MassTransit documentation is here, but the project is on github.com/masstransit/sample.library. And you can see sample.library. It has the first commit of the code. I'll put the updates of some of the tweaks that I did today. But that way you can follow along, see the code, and get the examples as you go along, and kind of take away some of the test fixture setup stuff into your own code. So thanks for tuning in, and we'll see you on the next one. Take care.